moving on with session 3, and something I'm very keen to see. It's about developing added value opportunities through plant proteins. I think we all know that the tillage sector has probably been challenged for many years by having to deal in commodity markets and therefore at the mercy of world prices and of imports. And I think this is a very interesting area that's been developing over recent years, looking to how we can add value to our tillage products and get out of those commodity markets. So welcome back to our attendees on Zoom, who should be just rejoining us. There's a question there for you on Slido, and also, as with the previous sessions, I'd encourage you to put questions into Slido by swapping over from the polls to the questions, and at the end of the session, we'll have a panel discussion around the area of proteins and adding value to tillage crops. So we have 3 speakers in this session, and the first speaker, Shay Hannon from Teagasc in Ashtown. Shay, would you like to come and make your presentation?
Thanks very much, John. Just to introduce myself, my name is Shay Hannon, and I manage the National Prepared Consumer Food Centre, which is based at Teagasc site in Ashtown in County Dublin. I just want to give you a quick overview of what the centre does. Again, it would be slightly different in terms of how we fall under the food research programme in Teagasc. So you might be more familiar, obviously, within this room with crops and land use, but within the centre itself, we deal primarily with the food industry in Ireland, and that's clients from small startups, enterprises, right up to the larger players within the food sector in Ireland. So the centre itself, the site in Ashtown obviously existed prior to the establishment of the centre, and really, I suppose, in terms of my background, and I've worked for over 15 years within the food industry, there was a need really established for this centre a number of years ago in terms of a physical site for companies, and particularly for startup companies, to come to and help develop and solve issues with problems with the development of food products. So the centre itself was established in 2018. We're extremely lucky to get a funding of up to 10 million euros from the Department of Agriculture, Food and the Marine, and that has allowed us to invest in state-of-the-art equipment. Everything from kitchen equipment right up to more advanced processing technology in terms of air drying, extrusion. And again, extrusion technology is something I'll touch on in terms of the plant-based environment later on. The PCF sector, prepared consumer food sector, is quite vast in Ireland. We have exports exceeding over €3 billion in 2020. And again, it's an extremely diverse sector. So really, if you go into any retailer across the country, you can categorise prepared consumer foods as any food product with the exception of alcohol or baby infant formula. So everything else you see within a retail setting is prepared consumer foods. And again, within the centre in Ashtown, we work with a number of clients. The centre itself is split up into a system of pilot plants. So we have many factories essentially on site, but we also have more advanced laboratories where we can conduct microbiological studies, nutritional studies, and we also have a separate wing of novel technologies as well, which we apply to products as well. So again, the centre, it's I suppose, a circular pathway of how we deal with food clients across Ireland. Some clients just come to us for facilities and our equipment. It can be as simple as renting out our pilot plant or renting out our kitchen to develop a new product, or it can be to work side by side with them. So it could be myself or one of our researchers, one of our technologists, working side by side with a food company to help start a food business, to help tweak a product, to help produce sugar or salt, or indeed in this space to help build and develop a plant-based product. Also within the department, there is a number of research projects ongoing. We have a research officer based solely within food industry development, Shivani Patania, and her research will be focused very much on plant-based alternatives and sustainable packaging formats. So again, the plant-based food sector, I suppose in the last number of years, we've seen a lot of growth within this sector in America and across Europe, and that has filtered very much into the Irish economy as well. And what's this really been driven by? I suppose there's a growing vegetarianism, and again, that's been led very much by the American market, a slight decline perhaps in meat consumption due to sustainability issues, and also an increased preference for plant food. purely consumer-driven preferences for plant-based foods. We've also seen, particularly in America, increasing venture capitalist investment in a number of companies over there in terms of the investment they've received in the last 10 years in the plant-based space. The market is quite sizable and growing, and by 2029 it's expected to reach $16.7 billion. Again, when we talk about plant-based sector, it's a number of different products, dairy alternatives, and you might be very familiar with all the different oat and almond, I suppose, milk alternatives that are available now in the market, and they're quite established at this moment in time. But also this categories into meat substitutes, and indeed you've seen a lot of them. If you go into any retailer now, a lot of retailers have given space to that market in the last 2 to 3 years, and it is a growing space in Ireland at the moment. But also plant protein is used, I suppose, as an alternative to traditional milk proteins now in goods such as baked goods, confectionery, and also in established ready-to-drink beverages as well. Just to give a background and looking at some of the statistics from our work last year within the centre, when we categorised the work we did, and we worked with over 160 Irish food companies last year, from startups to SMEs to larger companies, 36% of the projects we worked on we could categorise as plant-based or used a plant protein or a plant within the actual process itself. The 3 key categories we worked on were plant-based meat alternatives, and again we used a piece of equipment called extrusion technology to create essentially the plant-based mince, which go into a lot of plant-based alternatives now at the moment. But the key sector we worked on was plant-based milk alternatives. And indeed, some of the products you'll probably see on shelf this evening, if you do go into any retailers, there's a number of them that were actually developed at our site in Ashtown as well. But also, as I mentioned, plant-based proteins have found their way into traditional products such as confectionery and bakery. And that's an area we're working with a number of companies on now, is how to adapt the right amount of plant proteins so that it can perhaps make a claim of a source of protein or indeed a high protein claim as well. So some opportunities in Ireland, again, some common plant-based sources in Europe: soy, pea, lupin, yellow. Most pea protein which we bring into this country would be yellow pea, traditionally sourced maybe from Canada. But there's also other sources including oat, almond, and a growing demand, which we've seen the last year, for fava bean. Again, as I said, all these products are imported at the minute, and that's the key message that I want to get across, that lead times for these ingredients are increasing. And I'll give a simple example of a project we're working at the moment. If we wanted to order a milk protein, we could probably get that product in 2 to 3 days. If we want a plant protein, you're looking at a lead time of 5 to 6 weeks. And again, that's all down to the fact that we have to import our plant proteins at the moment. So this really presents a unique opportunity for Ireland to increase its native protein production, but also to ask the question, can we build an actual protein extraction factory? And indeed, that's the question what I will ask today is the growth, is the demand there, or the appetite really to build that type of processing facility where we could both grow, process and sell plant-based protein within the island of Ireland. We have established several processes. There's been a lot of research done already within Teagasc, and indeed Sinead will touch on U-protein as well, a large project that's running at the moment as well. But we have several projects ongoing at the moment where we're taking different plant-based sources and we are extracting protein in particular from those. Again, I've just given a very basic overview of the type of work we're doing here. But the process, again, we have 2 patented processes that are currently established at the moment. And a basic overview, there's a washing step, milling steps involved, and there may be some degree of chemical treatment. We're trying to focus on more natural treatment methods at the moment, more natural extraction methods. And that's where a lot of our research at the moment is directed. And again, there is stages then, separate stages to actually convert that protein flour, that protein mass then into an actual concentrate or a protein isolate, which is then dried. It could be spray dried, or indeed some examples could be freeze dried as well, and then packed. And that's to get your final protein powder. So just to give you an example of one of the larger projects we've worked on, a case study in the last 2 to 3 years, a company called IMSA approached us in 2017. Again, this was a collaboration with 2 other researchers in the department, Carlos Alvarez and Brajesh Tiwari. And what we teased out really with IMSA was there was an issue, indeed, with rapeseed and canola cake. So a lot of you may be familiar with rapeseed oil, and the process that's involved to actually extract that oil is a cold-pressed extraction process. But indeed, that rapeseed cake was finding its way either being dumped or it was finding its way for animal feed. But we did identify there was a high protein content within that rapeseed cake. So what did we do? We went about a series of trials to establish, was it a worthwhile project in terms of protein extraction, but how much protein could we actually extract from that rapeseed cake? And indeed, the initial trials proved quite favourable. We got a 50 to 60% protein concentrate rate from some basic extraction methods we did. So the project then grew. We worked quite closely with Enterprise Ireland, and through those various interactions with IMSA, we built a project with Enterprise Ireland called an Innovation Partnership. And indeed, what this allowed was Enterprise Ireland funded the project up to 80% of the overall costs, and IMSA then provided the remaining 20% of the funding. So the project ran over 2 to 3 years. It's still ongoing at the moment, but it has allowed us to take from lab scale, rapeseed extraction, protein extraction, right up to pilot plant scale. And just before Christmas, we ran some trials in our sister site in Moorpark in Fermoy, where we scaled up this process to 1.5 tonnes and then spray dried the process. Again, we supported IMSA on the European Food Safety Authority approval and applications because this was categorised as a novel food product. So we supported them with the analysis and the testing within Teagasc as well. So that can ultimately lead to IMSA producing this product and distributing it for sale. Again, just a brief overview of how the project was ran. Again, it's a quite in-depth project. It took a number of months to get funding through Enterprise Ireland and really get the project moving at lab scale. But again, it's a simple process. We took it from lab scale right up to our own pilot plant in Ashtown, 20, 30 litre capacity, and we conducted a series of analysis, amino acid profiling of the final powder itself. And we also gathered a number of data points for EFSA approval as well that IMSA needed for that submission. And at the current moment in time, 2022 up to 2023, it's now moved to full scale-up production. We also have a license agreement in place, so the process we established throughout this work, we now have a patent and a license agreement in place with IMSA. So just, I suppose, to sum up in terms of the demand for plant-based protein in Ireland and indeed throughout Europe, there is an increase in demand for plant-based foods. And again, it is a trend at the moment. How long that trend lasts, we'll have to keep looking at research and the Borbia reports to see into 2029, 2030, how long that trend is going to last. But it is established. The plant-based protein market is here to stay. But to produce the actual raw materials for those products, that's the key question. Can we do that in Ireland? Is the demand there? Can we actually build a facility that can produce, I suppose, the raw materials, the raw ingredients for those type of products? Again, I'll just draw attention to whey protein, and I know Sinead is going to touch on this as well. We were just having a conversation before, but a number of years ago, 20, 30, 40 years ago, whey protein and I suppose the outputs of cheese manufacturing, that I suppose whole process now has completely changed. Now we have very much an established process for whey and milk protein manufacture in Ireland. That wasn't always the case. So we would very much see plant protein at a similar trajectory to establish the process and then continue growth and then continue into export then as well. So I'll hand back to you, John. Thanks.
Okay, thanks, Shay. Maybe you'll come up and join me here. And Sinead Fitzsimons, who's making her way up to the podium. There's a step this side, Sinead, which might... you don't want to be falling off the stage before you get on it. Who's going to tell us about U-Protein, Department of Agriculture funded project about developing these plant protein resources in Ireland.
Okay, thanks, John. So yes, I'm going to talk about U-Protein. It's an acronym, all right, for unlocking the protein resources within Ireland to evolve Ireland's nutrition. So giving a bit of my background, I'm the project manager. So behind me, there's 40 plus researchers, and I'm here today presenting their work and the work that they have produced over the last 2 years. I'm based in Moore Park, and I suppose the coordinator for the project is based in Moore Park, which is probably traditionally dairy. But as you see, we're using the expertise that we've probably built up in Teagasc on the dairy side to transfer these skills over into plant. So from U-Protein, I suppose it's 6 research tasks. It's the Department of Agriculture, Food and Marine funded project for it's a €3 million funding that we have for a 5-year project. So we have the five Teagasc centres and 5 universities. And then behind that, we have industry partners who are sitting on advisory boards and making sure that what research we're doing is relevant, and also keeping us in contact with the consumer and also trends. So if we look across the tasks, they go, and they're all a feed-forward, feed-backward mechanism between each task. So we're looking at everything from the seed right through to human nutrition. So we're going to be feeding the food products that are developed to people and looking at what are the outputs and looking at what is the nutrition implications for the foods that are produced. So task 1 is all about land use and sustainability. So we're looking at all of the inputs and the outputs and the yield and all of the sustainability indicators. So by the end of the project, we will have, say, life cycle analysis and data that we can compare the plant proteins that we've chosen against other proteins and have a complete picture of how the proteins stack up. Task 2 then is tasked with growing the crops. So I'm probably talking today about the crops. We've also got a grassland and a marine aspect to the project as well. So they're looking at the crops that are the best crops to pick. So we had a selection criteria that I'll go through it during the presentation. And once grown and harvested, these crops then move on to task 3. So task 3 is primarily based in Moore Park. After being grown in Oak Park, moves to Moore Park, and we're looking at extracting protein. So what we're looking at here is protein as an ingredient. We're looking at its functionality. We're looking at the best way to extract the protein. What's its yield? What's the protein profile? And then its functionality, which becomes key when you're looking at an ingredient. To us, I suppose, and to the researchers, it's just seen as an ingredient, whether a protein is a protein, and look at its functionality. So I'll discuss a bit of that through the presentation. Then task 4. So once you extract the protein, so you have a biomass, and we're looking at the biomass. So this goes back to Shay was indicating that I'm going to just talk about how whey was the biomass, I suppose, or the waste product from the milk industry, and now is kind of dictating what production of cheese is going on, because whey has become such an important ingredient. And what we're looking at here is we're lucky, I suppose, in Teagasc to have a culture bank that we can look at biotransformation and cultures that can transform this biomass into, we've looked at lactic acids, we've looked at volatile fatty acids, biofuels, bioactives, any kind of a functional ingredient. So we'll take another ingredient out. So what we're doing is, I suppose, stripping the crop into its component parts and looking for uses for everything, and then coming back to minimize the waste. Protein profiling then is task 5. So we're looking at every aspect of the protein, really deeply looking at what amino acids are there, what's the protein profile, how does that react when you firstly put it into in vitro digestion. So when you're trying to break it down, what's the byproducts, what's coming out once you digest it, what's its digestibility like, and then you can start comparing protein on a like-for-like basis. So it'll be completely profiled in this task, and that'll lead on then to the human nutrition trials. And then task 6 is very important, because we could have the most beautiful protein, the most functional protein, but if you can't eat it and it's just, it doesn't taste right and it doesn't feel right in your mouth and all of that. So this work is going on in task 6. And there's ways that we know from other proteins that we can modify the functionality and make a protein work the way we want to do it. So as we're going through, I'll just discuss some of the applications. So we are looking at, I suppose, what people are used to, the dairy type drinks. meat, and prepared consumer foods. So that's where our overlap then comes in with Ashtown and the work that Shay's after going through with you. So the dairy analogy, so as I was saying, the milk was the cheese and whey, and the whey just went for pig feed until we start looking at it, and now we're feeding it to our most vulnerable consumers. So we're feeding now to human, or to babies, and we're feeding it to geriatrics, for geriatric nutrition. So we have a lot of experience with this, I suppose, in Moore Park on the infant side. We have a lot of companies working with us. So there's ingredients, we've now broken whey down to its individual components. So you can have there's multiples of ingredients that can be extracted from milk, and all finding value. And sports nutrition, I suppose this is where whey really kind of was launched into everybody's knowledge, was the recovery in sports nutrition. So when we were looking at crops for U-protein, first of all, U-protein is all about Ireland. So the crops have to grow in Ireland. So it had to produce a high yield potential in the Irish climate. It had to withstand Irish conditions. There had to be protein in the plant that we could extract. It had to have a residual biomass. We didn't know what we were going to do with the biomass at that stage, but we were going to screen to see what would break down the biomass. The quality and safety of the protein was important. Good sensory properties, but again, we could modify that, and we have some ways to modify the sensory properties and the potential for circularity. So there was a kind of a good story. So we have now, we've narrowed it down to fava beans, peas, lupins, lentils, masho, and aca. So some more traditional and some more out there crops that we've narrowed it down to. So from one of the researchers in task 3, where they're looking at extracting protein. So what we're looking at is a very concentrated protein. So we're looking at the isolate version. So that's anything from 70% protein plus. So we want a lot of protein. The problem with wanting a lot of protein is that you don't have a lot of product. You want the protein content, but the mass is low. So we're working at the moment at lab scale and understanding working at understanding the protein. So they're then working at ways of solubilizing the protein, and then once you solubilize it, then to extract it and dry it so that it becomes an ingredient that we can look at. So at the beginning, when they started looking at it, we were getting about 80% protein, which is good, and the extraction yield was only 63%. So the researchers have looked at this and have optimized the process to standardize it so that they can then use it for all of for the crops as we go forward. So we have a standardized extraction process. So these are the conditions that we've set on for the extraction process for fava beans. So now our protein content is 88%, so we've upped the protein content significantly, and the extraction yield is much, much better. So that's the amount of protein we're getting out. Of the protein that's available, this is the protein that we've got out. So for fava beans, we have narrowed it down to 7 varieties that we've looked at, we started looking at. So this is for the first year's harvest, we've extracted the protein. So we see that we're getting anything from about 81 to 90% protein in our isolate. So what the researchers are now looking at is like there is a difference. We're looking at the amino acid profile. These have all gone for protein profiling, and all of the ingredients are going for digestion. In vitro digestion at the moment because quantities are low. So we've been working on this. We've also looked at the anti-nutritional potential and the potential linked with processing. So Shay was talking earlier about we're trying to minimize the extraction, minimize and improve the sustainability. So depending on what way you extract the protein, you will then affect the anti-nutritional properties and the anti-nutritional in the protein ingredient. So as I was saying there, the protein is tested for in vitro digestion and then going on to human trials. And the biomass, they're showing good promise for organic acid. So we have identified cultures that will produce lactic acid, which has great use, anything from just adjusting pH, so food grade lactic acid, so adjusting pH within the food formulation, right to bioplastics and biofilms. So that's the potential for that, and that's from fava bean or biomass. We're also looking, the picture you can see here, so this is looking at colour, so producing beta-carotene from the biomass. So the top picture is actually our controls. This is using just glucose. And when you put the biomass in, you see the orange is much more intense, showing that it has good potential now to produce beta-carotene. The other ones then, the volatile fatty acids as well, have options then. This is where the work is going on. So what we're working on here is that instead of having a seasonality effect where you turn on and turn off a factory, where if you have a mixed culture, you'll be able to then feed the cultures and your process different crops depending on what's available and what's in season. So you're kind of making, it's not an on-off process, which I suppose traditionally dairy would have had a window and then you have your off seasons. This is now when we have a mixed process, can we then manipulate the process to be able to cope with different food sources or crop sources or biomass sources. So this is showing potential now and the work is going on in Galway at the moment. And then the sustainability models are being developed. So all the information, although it's the first task and you say, oh, well, that's the first step, it's not actually. All the information has to go back up into task 1 to be able to fill in all the gaps. So we've found some gaps within the data for Ireland, and where that is at the moment for model building, we're using international data, and then that'll be input, or the data will be inputted for the protein data or Irish data as it becomes available. So our next step. So within Moorepark, we're lucky to have a pilot plant, Moorepark Technology Limited, and this is traditionally dairy, traditionally a lot of companies coming in and out of it, and we would all have used it. And me, in my previous role in industry, would have been in MTL a lot. And what it's used for is companies, when they're wanting to scale up, understanding what how to process it, kind of large pilot scale. And then also, at some point, because it's BRC accredited, you could have production there for retail. So we've now got new equipment. So we have cleaning equipment, dehullers, a tray dryer, all for upfront processing of crops as they come in, and then we can use the equipment that we have. Anything from scale from 10 kilos right up to 200 kilos per hour we can process at the moment. And this is just at the moment being commissioned. So what we're going to do then is, because we're at bench scale, we'll be moving on to protein extraction and biomass production at a pilot scale, at a fairly substantial pilot scale, that we can now produce ingredients that we can send on to task 6 so they can make food and understand what's going on and make sure that the food product has the sensory properties and the functionality properties that are required. For example, say if you were looking at a coffee drink, you may want it to foam, which is a great property for protein. They're very good at it. But at other times, you don't want a foam. So if you're feeding an infant formula, you don't want a foam. You don't want a massive foam that you can't see where your levels are and you're introducing a lot of air. So it's that type of work now that is going on for the food side of things. And also then for meat, when you want texture and you want mouthfeel, you want water binding, on fat binding, all of that has to be understood and worked on. The LCA models, they are being generated within the project, and now we're looking at where are the gaps. And then the yields, we're looking at the yield for improving the yield for both sections, so it becomes profitable. So you're looking at the yield for the protein plus the yield for the biomass and having a whole picture. So as I say, there's 40 plus researchers working on the project. The project is funded by the Department of Agriculture, Food and Marine, and then these are the research is all based on these 6 different institutes. So.
Thanks, Sinead. You might come over and join myself and Shay, and whilst Ewan makes his way up to the platform to tell us about another project in this area, which is just beginning, Ewan. Yeah.
Val Pro, Pat. Sorry.
Yeah.
Yeah. Thanks, John. So this is going to be very short. So ValProPat is a new EU-funded project that we secured last September. And I suppose it's a testament, and it's important to point out, funders such as the Department of Ag and other national funders, they provide that funding with the goal of stimulating potentially success at a European level. And this is a great example. It was because of U-protein and the success of that, even in the first 12 months, that we were then used that template and we successfully applied and secured funding through ValProPat. So the title is there, and basically the ambition is to demonstrate novel value. You heard from Shay this morning, or earlier, sorry, the potential that's there from the food side. And U-protein was the first project to bring together the multidisciplines, food, crop science, agronomy, food processing, nutrition, all of that together to try and develop a roadmap to see how this can be ideally developed as an industry to support the tillage sector and give added value opportunity. Because we know from Crops 2030, we have to develop added value opportunities to support the sector going forward. So really what it's about is can we get more value from what we already produce? And it's important to say what we already produce very, very well. We secure some of the best yields in the world and definitely across Europe. So there is real potential there. So ValPro is stepping out. It's looking at it across it from a European landscape. And why do we need it? Well, from a European perspective, the plant protein landscape is really not fit for purpose. This may seem quite a strong statement, but it was the opening statement in our proposal. And it was there because we don't have those premium supply chains in existence. Obviously, plant protein that is being produced at the moment, its primary goal is to go into animal-based systems for feedstock. But looking ahead, and that's what projects like this is all about, in terms of climate resilience, nutrient capture, we know there's so much more these crops can achieve. And then that circularity potential. So, I mean, what does that mean? Sinead touched on it there. It's basically when you get that residual biomass, you don't look on it as a waste product. We have to look on it as another opportunity. But maybe we don't know what that opportunity is yet, and we haven't fully characterized it. And then from our perspective, specifically in Ireland and obviously across other parts of Europe, diversification and rotations is going to be absolutely essential. So we see this as key. So the other aspect of it, Shay mentioned societal awareness. We know there are trends around plant protein, but it's not just a fad. It's definitely something that's tangible. Carbon neutrality, traceability. But one of the key points is the consumer's willingness to pay. As farmers, you all know, the sector knows that there's an increased amount of paperwork and more pressure to enact more management change. But is that premium, is that value coming down from the other end? So within ValPro, the goal is to co-design. So that's not just researchers sitting around a table coming up with ideas, because it has to be multi-actor, it has to be multiple stakeholders, and within ValPro, that is indeed the case. The idea is the right crop in the right place for the right market. So that market could be local, it could be regional, it could be across nations, or the other side of the European community. And the key bit then, of course, is to get stakeholders to transition. But to be fair to stakeholders, we have to demonstrate the potential in real terms, economically and in terms of sustainability as well. So this looks quite complex, but it's basically the workflow of, or the goal of what ValPro is about. And it starts out with the work package 1, 3, and 4, and really that co-design step is the first bit. In some of the initial discussions that have been had within Work Package 1 with stakeholders across Europe, it's very clear that the ideas are there, the solutions to many of the problems have already been discussed, but it's actually pulling them together so that we can demonstrate solutions through Work Package 3 and then out to the evaluation steps. And all of these work in a loop, similar to U-protein, so the feedback from the evaluation goes back to re-optimize the co-design. So it's not just we come up with a solution through the co-design and then we pass it on and sit back and breathe a sigh of relief that the task is done. No, it's a constant feedback loop. The core part, though, of the project is this bit here, the most exciting bit. There are 5 systems, or in Europe they're called living labs, which is a term used, but I suppose it's really about research and practice. There's one system which is about on-farm processing. So, for example, in regions of Italy, many of the farmers producing plant protein crops have the capacity on their own site or within a local co-op to do processing post-farm gate processing, which facilitates the industry then in terms of, I suppose, diversifying the outputs from the farm and going into different food processors. And you might think, okay, that's going to be an added cost. But really, in those scenarios, it's obviously working because the farmers were not going to invest the money if the opportunities weren't there. And the food processors, that's what they want because they're getting material at the grade and the condition that they need. Varietal selection is a key issue across Europe. The agronomy actions, what are we talking about there? So, for example, pea is a great crop, but it's susceptible to lodging. And work that we're doing here in Oak Park, led by Sheila Alves, is looking at intercropping faba bean with pea. And Sheila has shown in the last 2 years of trials that actually works very, very well, with the faba bean acting as a scaffold so that the pea latches onto it. The pea can stay upright. It opens up the window for harvesting, and I suppose it reduces the risk of loss of pea. And then you have a dual crop, faba bean and pea coming off the same site. Nutrient tracking, we have some of the largest food companies in Europe involved in the project. And the nutrient tracking is important because they want from the farm, from the field, all the way through to the shelf. They want to put informative labeling systems on their products. And that's a key component there. It sounds quite a simple system, but when you start to introduce all the inputs that are going along the system in terms of carbon footprint, etc., that all has to be in there. And then this cross-regional production, that's what I mentioned earlier. Something that's happening in one part of Europe could be working very well in another part of Europe. It's never really been looked at, but it could be equally applicable, and hence that opportunity is there. The core bit, though, is that all the work that is developed has to be developed into business models, and our partners in FSH are doing that. So the project is only 6 months. It's a 4-year project. Richard Lynch is the manager and is in the audience, and he has posters outside. So please, if you want to know more, I would encourage you to take a moment to look through the posters and obviously ask Richard any questions. And we're very lucky to have all these partners, very proactive partners involved, and that touches across the whole chain, both from a research to a university, all the way through to, as I said, some of the biggest food processors across Europe. But the key feedback we got from our kickoff meeting from these large companies is that they want more plant protein. Just the key thing for them is consistency of supply. That's what they need the reassurance on. So thank you.
Thanks, Ewan. And I'll also ask Kieran to join us up on the podium for the Q&A session, which we have a few minutes for. You'll be pleased to hear I don't intend to keep you from your lunch. So the poll that was on during the session was to rank the following benefits to protein crop production on you or your clients' farms. And I don't think we'd necessarily disagree on it. It's a very production-orientated question, Kieran, so maybe you'd like to start off in terms of commenting?
Straight at me, yeah. Yeah, certainly you couldn't disagree with all of them. I suppose protein crops offer all of those. You know, we're in a climate, farm food to fork, and we're looking at reductions in fertilizer use as well. So, certainly the legumes are offering that. And we've seen from, current work and previous work, the boost in the rotation. So I think that's a given as well. So all of those, yeah, certainly benefits. And I suppose we are looking at, if you look at again, back to the Green Deal and farm food to fork, the targets that are there, in terms of acclimatise, we're looking at 40,000. There's a protein aid scheme there that will facilitate up to 20,000 hectares of protein crops. So, that's the direction of travel, I suppose, John.
Okay, thanks, Kieran. I didn't go onto the poll myself, but I would hope that all of the above was one of the potential answers. Yeah, because I say they're all benefits. Now, the first two questions, which are really to do with livestock, and we don't obviously have any livestock people on the panel. We'd be happy to answer them afterwards or discuss them afterwards. So we'll go to the third one, which is the plant-based protein options seem to be very processed food compared to natural milk or meat currently available. We know processed food is bad for you. No, I'm not a food scientist. Shay, I might ask you, and then you can move on down the line.
Look, I'll be honest. I think we're all aware in this room, indeed online, of the negative rap that a lot of these food products have got. in particular the meat alternative section. And it is something we are researching, again, from a nutrition perspective, and Sinead touched it from the digestibility as how healthy are plant-based products. If we have to have an ingredients list, as long as the back of a pack on a product, is that worth pursuing? But most of the projects we work on will be very simply, very basically processed, particularly through extrusion, where we could take one protein, a soy or a pea protein, and we might only add wheat gluten, and that essentially is your recipe. So we're not adding any binders, preservatives, salts, and that's all down to the technology used. But it is a good question, and something, as I suppose companies are putting more research into what they actually add to these products to preserve them and to flavour them and colour them. And it's something we certainly will have to keep in mind for future research and development.
I don't know, Sinead, do you want to comment?
Yeah. And I suppose I'd agree with Shay. Probably what has been traditionally on the market as plant-based has been quite highly processed, but the market is starting to be more clean back of pack, and that's a big push. And like that, you can get ingredients, plant ingredients, anything from a flour right to a protein isolate. So it's just that, it's that formulation, and as ingredients become more available, then you're able to maybe reduce the other ingredients and have that modification based off the plant functionality. So yeah, there's probably advances being made in the area.
Okay. Do you want to comment, Ewan? Or?
Yeah, because I think the other point here is that this discussion needs to be broadened much broader than this. Like, it's a systems perspective, and plant protein crops, they have the potential to provide an ingredient, obviously, for food production systems, but they contribute so much more in terms of sustainability, biodiversity, in terms of pollinators, the ability to fix nitrogen and reduce nitrogen going to a follow-on crop, which is work that Kieran is working on. So we can't look at it in a single lens.
Okay. Whilst you're talking, Ewan, maybe the question at the bottom in a few simple sentences. Farmer language.
Yeah, okay. Valpro is basically, it's about getting added value from something that we already produce. So it's you already produce it very, very well. It goes to a certain system after it's harvested, but there's real potential there, and that's not just through my biased opinion, but that's based on the feedback coming from the food industry. We've heard speakers today talk about it, that there is added value potential there for producers. There's a lot of work to be done, but the template is there.
And it's my understanding, Ewan, that all of this work is focused on not just adding value to what a farmer supplies, but delivering some of that value back to the farmer in terms of a premium for what they produce.
I mean. Yeah, it's added value for the primary producer.
Okay. Shay, have you compared the carbon footprint of plant-based foods that include imported ingredients like soya versus locally produced food?
It's an excellent question, and I suppose it's something I've asked that question around a way in my presentation. There's no work being done with our department at the moment in that area, but we have seen from research published in the last number of years, it is a question we're asking. If we have to import tons of plant ingredients, of the raw material, how sustainable is that? And that's what I'm really trying to get at today. Can we build that ourselves within Ireland? Can we actually produce this raw material from our own native crop? That's the key question, which I suppose I would put back to that.
Does anyone else want to comment on that? Or?
Yeah, no. The only thing I would like, it's maybe stating the obvious, but high value crops is what we want. We've seen the success of our malting and distilling and our brewing and distilling industry, where you're getting a premium over feed, and I suppose this is what this work ultimately leads to, better economic returns for farmers.
Okay, on the LCA, I might comment as well. We are just at the beginning to develop a life cycle analysis for Irish-grown crops using Irish emissions factors rather than standard international ones. And the models that we have within Teagasc for beef and dairy, they can take account of where the ingredients of a ration come from. But obviously you can't use that information unless it's available to you. And currently within the feed trade, you can't get information about where the ingredients in a livestock ration came from. So therefore it's difficult to give, to build a value on low emissions ingredients in a feed ration. In terms of soya, if you look at the figures, generally there's a very low carbon footprint associated with putting something on a boat and sailing it around the world, surprisingly. But if you compared soya from an established tillage area in the world, it wouldn't have a huge carbon footprint. It would be slightly higher than than most Irish products. But it's really when you look at these products, whether it be soya or maize coming from South America and where it's associated with deforestation, that's when you get the huge emissions associated with the raw ingredients. But as I say, we are currently developing or just beginning to develop an Irish life cycle analysis that will be well calibrated for barley or beans or whatever crop you want to produce in Ireland, which presumably will build into the work that Shay and Sinead are doing. We only have a minute left.
I can take that.
Maybe the last one. Has the government expressed any interest in developing plant-based protein, or will this opportunity fall by the wayside like biofuels? We don't have any politicians here to answer it, but I think Ewan did point out that there has been funding put in this area.
Yeah, well, we have U Protein, that's €3 million. There's another project led by UCD called Protein I that ourselves and many others are involved in. I think that's another 3 million. And it's definitely not, as I said, a fad. It's consistent, and there's a clear realization that the investment given to this for research has to deliver outcomes that will affect the sector.
And I think as well, there's companies as well starting to work with Enterprise Ireland to look at options for production of plant protein ingredients. So there is work going on.
I'd echo that as well. A lot of the case study I made reference to with IMCEL, that was funded by Enterprise Ireland, €120,000. So certainly the funding is being made available by government departments for this work.
Okay, thanks very much. I'd like to thank the panel. We're down to 8 seconds left. I'd like to thank you for your attention and for your questions, whether you're in the room or on Zoom. And for those of you in the room, we'll be back at 2:15.
Yeah.
After lunch, and we have a Zoom session then later on in the afternoon again. So thanks very much.